Hey everyone, I'm Raviteja from KL University, Hyderabad. Here we are with another interesting topic which is activation function. So let's start. What is activation function? So an activation function uh, is a thing that decides whether a neuron should be activated or not. To map within general surroundings, we can say uh, the perceptron as a neuron, right? So when we put it on a hot vessel or something on a hot place, our brain immediately reacts to that and says like, and it activates some sensory organs and tells them to remove that hand, or when you click on a vessel it will say like, yeah, remove that hand. So like as the neuron is activating our organs or something else, in the similar way, activation functions are responsible to activate the perceptron in the neural network. To put it in simple terms, in an artificial ca- calculates the weighted sum of its inputs and adds its bias by the net input. Now, the value of the net input can be anything from negative infinity to positive infinity. The neuron doesn't really know how to bond the value, and thus this is not able to decide the firing pattern. Thus, the activation function is an plays an important part and of an artificial neuron, and they basically decides whether the neuron should be activated or not. Thus, this bounds the value of the net input, and the activation function is a nonlinear transformation that we do over the input before sending it to a next layer of neurons or finalizing it in the output layer. So coming to the next point, we are having three types of activation functions, which first one is binary step activation function, linear activation function, and non-linear activation function. Just to remember, uh, every perceptron has this weighted sum, like it takes the inputs and multiplies with the weights and adds it to a net sum, and then adds to a bias, and this whole net sum will then be used for an activation function with which the output gets triggered. So binary step activation function. This is one of the simplest kind of activation function. In this, we consider a threshold value, and if the value of the net input says y is greater than the threshold, then the neuron is activated. So here we can see the mathematical representation of that one. Like f of x is 0 when x is less than 0. That's what happening in the graph also, and it's greater than 1. It is equal. It is set to 1 for all the x or the net sum values, which is greater than or equals to 0. So it's similar to a switch, right? When we say on, then the value goes up and it triggers to 1, and then for every no known values it will be off. So we can say when the power is there, then only the step activation function gets triggered. If no power, then nothing will be happen. So coming to the next point, linear activation function. Linear activation function is also known as identity function, where the activation is proportional to the input. Here is the mathematical representation of it. F of x is equals to x, which means for every calculated net sum, if we do the activation function, it will be the same. And when we talk about why do we use linear activation function, we can say that all the layers of the neural network will collapse into one if a linear activation function is used. No matter the number of layers in the neural network, the last layer will still be the linear function of the first layer. So essentially, a linear activation function turns the neural network into just one layer. This is also a limitation this point also comes into the limitation, as when we talk about the complexity is increasing, then if we directly trigger it to one thing, then it would be a problem. So we need to add some non-linearity in between the hidden layers to make the model more efficient. So that's why we come into the next point, that is nonlinear activation functions. So as discussed, linear activation functions are limited to the with the power. It does not allow the model to create complex mapping between the network's input and output. We introduce nonlinear activation function. So here are a few linear activation function listed below, in which there are Sigmoid, TanH, Relu, Leaky Relu, parametric Relu, and so on. So in this we'll be mainly focusing on Sigmoid, TanH, Relu, Leaky Relu, and Softmax function. So let's continue on this. Sigmoid activation function. It's also called as logistic activation function. This is a smooth function and is continuously differentiable. The biggest advantage that it has over step and linear function is that it is non-linear. This is an incredible cool feature of the sigmoid function. This essentially means that when I have multiple neurons having sigmoid function as their activation function, the output is non-linear as well. The function ranges from 0 to 1, having an S shape. The main reason why we use sigmoid function is because it exists between 0 to 1. Therefore, it's specially used for the models where we have to predict the probability of uh, sorry where we can predict the probability of an output. Since the probability of anything exists only between the range of 0 to 1, the sigmoid is the right choice. As the function is differentiable, that means we can find the slope of the sigmoid curve at any 2 points. The function is monolithic because the function derivative is not. The logistic sigmoid function can cause a neural network to get stuck at a training time. So add on to that, this is the mathematical function that sigmoid activation function uses, and this is the graph of that. Moving on to TanH activation function. It's also known as hyperbolic tangent. So TanH function is very similar to the sigmoid logistic activation function, and even it has the same S shape you can see here, with the difference in an output range from -1 to 1, where in sigmoid case it was from 0 to 1, here it's -1 to 1. In TanH, the larger the input, more positive we can say, the closer the output will be to 1, whereas the smaller the input, i.e., like we can say like negative, the closer the output will be to -1. Mathematical representation of the TanH function is this one, and this is the graphical representation of it. The advantage is that the negative inputs will be mapped to strong. The advantage is that the negative inputs will be mapped strongly negative, and the zero inputs will be mapped near zero in the TanH graph. This function is differentiable. This function is monolithic while its derivative is not monolithic. TanH function is mainly used for classification between two classes. Both TanH and logistic sigmoid activation functions are used in feed-forward nets. Relu function. Relu stands for Rectifier Linear Unit. Relu is the most used activation function in the world right now, since it is used in almost all the convolutional neural networks or in deep learning right now. Although it gives an impression of a linear function, Relu has a different uh, derivative function and allows for backpropagation while simultaneously making it computationally efficient. The main catch here is that a Relu function does not activate all the neurons at the same time. Now, as you can see in the image, the Relu is half rectified from the bottom. F of z is 0 when z is less than 0. Here I mean z is as x. So f of x is 0 when x is less than 0, and f of x is equals to x when x is above or equal to 0. Now we can say that the range is from 0 to infinity, and this function, uh, the function and its derivative are both monolithic. But the issue is that all the negative values become 0 immediately, which decreases the ability of the model to fit or train from the data properly. This means any negative input given to the Relu activation functions turns the value to 0 immediately in the graph, which in turn affects the resulting graph not mapping to the negative values appropriately. So these are few points on Relu activation function. Starting with the leaky Relu. It's leaky, right? The leak helps to increase the range of the Relu function. Usually the value of x is 0.01 or so. So we can say the main catch here is this point. When x is not 0.01, then it's called randomized Relu. Therefore, the range of the leaky Relu is minus infinity to infinity, where in case of normal Relu, it was from 0 to infinity. So as this name indicates, it's leaky. It's leaking the thing to negative infinity. We can remember the points in that way. And also a point to add on, both Leaky and Relu functions are monolithic in nature. Also their derivative are also monolithic in nature. So softmax activation function. In the previous slides, we were talking about sigmoid activation function, right, which is also known as logistic activation function, which works for calculating the probabilities, right? And its output lies in the range of 0 to 1, which can be thought of as the probability we have discussed in the previous slides. So similar to that, softmax function calculates the probability distribution of the event over n different events, we can say. In general way of saying, this function will calculate the probabilities of each target over all possible target classes. Later, the calculated probabilities will be helpful for determining the target class for the given inputs. The main advantage of using softmax is the output probability range. The range will lie between 0 to 1, and the sum of all probabilities will equal to 1. If the softmax function used for a multi-classification model, it returns the probability of each class, and the target class will have the high probability. When we talk about the usage of softmax function, it is used in multiple classification logistic regression models, and in building neural networks, softmax activation function is used in different layer levels. Finally, I would love to add few bonus points here, as we know that choosing activation function for model based on the type of prediction problem that you solve are difficult. So I would love to add few bonus tips here. The activation function that I add here are recommended in the global level too. So for CNN based like convolutional network based architecture, we recommend using Relu activation function, and for regression we recommend using linear, and for binary classification, logistic activation function, multi-label classification, sigmoid, multi-class classification, Softmax. So these are recommended at the global level. So you can use them when you need. Finally, thank you for listening to my tutorial. Thanks.